Okay, hello everyone. So we hope you all are doing good. So we welcome you on the third day of our 5 days online workshop on designing on SolidWorks. So again, today we will be joined by Mr. Pratik, our senior trainer with FMA Academy, and today on also we will be using all the features on SolidWorks, wherein we will cover. Uh, 2 to 3 models where we will try to use the maximum number of features from SolidWorks. And this session is going again will be like for next 90 minutes. So please make sure you will uh, be there with us throughout the session. So uh, hello Pratik, can you please share your screen and can you continue from here?
Yeah, sure, sir.
Okay. So, for everyone, those who are joining us live on YouTube, throughout the session, if you will be having any doubts or any queries, you can please type in the chat box there. So, we will take all the doubts by the end of the session. So, please, let's just start.
Hello, everyone. Today we are going to start with some more features in SolidWorks, and we'll try to cover some good models from some of the parts from our IC engines, like cylinder, connecting rod of our engine, and all. We'll try to complete at least two parts, and if we have time, we'll go for the third one as well. So let us start from the beginning again. I'll explain you some more features by using which you can reduce your design tree and make your part and model very simple and in less time. We'll quickly start with the part. We'll select new and start with the part section. After coming to this, first of all, if you're starting directly with your sketch, make sure your dimensions are set properly. I'll show you some more features in this, which are combined both in sketch as well as features. So one by one, I'll start with the part which you can see this on the canvas. You have your zoom in and zoom out in this, so you can just zoom to whatever part, whatever sketch you're making in this. You can zoom in and zoom out accordingly. You can also use your scroll button and scroll it up and down to zoom in and zoom out. That is also a shortcut for it. The section view I have explained in the yesterday's session. This is the view and the orientation. As you can see here, I'll make a simple sketch and show you an example of orientation. We'll make a cuboid. We'll make a center cuboid here. I'll quickly give dimension to that as 100 by 100 mm. Then I'll go in the features and extrude it. And again, I'll give 100. So we have a cuboid here. You will go in this, you can click on the side arrow, and also you can click on that. I'll show you both. When you click on the side arrow, you will get different orientations from the side which you want to see. So first one is the front plane, then you have your right hand side plane, left hand side plane, top view, bottom view, whatever plane you want to see and want to start your sketching, you can select it from here as well. You also have this part here, which you can, by clicking on the scroll button and moving the mouse right and left, you can move your any sketch which you want to. These side views are isometric views. If you want to view your model from an isometric view, you can use this. You can again click on this. The view will come according to the side where you want to start your sketching. You can just select and start your sketching. This was your section view. Then you go in different types of views. In the displays, you have different types of displays for your model. Wireframe model, hidden lines removed, and shaded one. So you can see if I change the orientation of it, in the wired one, you will only see the wired part, or you can see, say, only the outer lines of the model. You can change it again to your shaded edges. After this, you can see a eye here, which defines various hidden and unhidden commands you can say, which are also available in this file option and other command bar toolbar options. You can select from this whatever you want, the axis, the temporary axis, or the axis which is seen, which is not seen. You can hide it and unhide it from here. These are the same planes which we have on the right left hand side here. One by one I'll show you that how to use this as well. This is the coloring appearance again. You can edit the appearance and scene from here, and the setting. So you can have different sides and different types of models seen in this orientation. After completing with this basics, we have some options here, as you can see in the reference geometry. In this options, you can see first one is a plane axis coordinate system. I'll explain you one by one how you have to do it, how we can use these commands. Very firstly, whenever you make any sketch or a model and you want to use this feature called as reference, you have to make sure that you are exiting from the sketch here or from here. Once you exit the sketch, then and then only you will be visible the references whatever you want to take. If you are in any particular sketch, this will not be seen or this will not be available. You have to compulsorily exit from the sketch before you go for any reference plane or reference axis. So to use this command, how this command is used, first of all, you need to know your three planes: front plane, top plane, and right plane. Now this is my 3D model. I want to make a reference plane to draw something for this particular sketch. If we take an example of this, you'll go in the reference geometry. You'll select plane if you want to take a reference plane. You can see on the left hand side you have first reference, second reference, and third reference. According to the plane which you want to, from the reference, you have to select other reference planes to put in here as an input. So if you want any plane which is parallel to your front plane, which will obviously be seen parallel on this side, on the first reference you will put front plane. You can see there is one plane which is reference plane coming parallel to your front plane. I'll just delete this model so you can see it clearly. So I'll go in the features, make sure you are exiting the sketch, go in the reference, select plane. For now, I'll show you how to take a parallel plane, which is a reference plane of my front plane. So in the first reference, I'll put front plane, and you can see there is one plane which is coming here, which is parallel to my front plane. Here you can also give distance to the parallel reference plane which you want. For example, you want a plane which is parallel 100 mm apart. So I'll put here 100. That plane will come according to the distance you will put, which is parallel to the plane which you want from the reference of. You can also flip the direction of this plane if you don't want it on the right side. If you want behind it, you can flip here, flip offset, and the plane will go on the back side as well. You can take number of planes according to this. So here you have number of planes. You can put here how much you want. So 2, 3, 4, you will see. You will get number of planes on which you can start drawing your sketch. After selecting this, you can click on right button. You can see I have 3 planes here according to the distance we have given, and the front wheel as well. After taking this planes, you can just right click on the plane and you can get a command sketch here. You can start sketching on that particular plane, or also you can right click here and you can start sketching on this. Right clicking on any plane, your sketch will only and only appear to that particular plane. One note here that it is not compulsion that the drawing will only and only come inside this box or inside this plain blue. You can increase this box anywhere and however you want, and the diagram which you will be drawing will be anywhere in this canvas but only on this particular plane. So whatever things I am drawing will not appear in the second and third plane or any other area. It will only appear on this plane. So make sure that you select the proper plane from wherever you want to start sketching. This was about parallel plane. I'll just quickly show you different type of plane as well. I will for now delete this, and I'll explain you how to take a plane in a particular angle if you want it in some angle. For that I will have to draw something. So I'll just draw a square here. After drawing square, you can see there is no plane appearing, so you have to take care that you're exiting the sketch. Then go in the feature, reference geometry, select plane. Now it is not a compulsion that you will only get a plane which is parallel of any three planes. You can also select points and lines as the reference here. So the plane will appear from that particular point and that particular line. So for the first reference, I will select one end of the point. The second reference, I will select the second point. You can see that I have got a yellow box here. You have to make sure that the third reference which you are going to select here should be a plane, not any point or a line. It should be a plane which is perpendicular to this yellow box. So quickly will that plane should be selected from these three planes only. So your top plane is your perpendicular plane, I suppose. I'll select the top plane as the third reference here. You can see I have got an imaginary plane here. Now you can give the distance to this plane, as well as from here you can give angle to the plane. You can, if it's not visible or not coming, you can click on the angle and you can select in whatever angle you want your plane off. So I can write here 180 degree. You can see we are getting an angle. Oh, sorry, we are getting a plane which is in the 90-degree angle of the previous sketch which we made. And then you can click on right button again. If you start drawing or sketching on this, you can even connect the lines which you have because the plane is passing to that particular point and the line. So I'll draw another line or a square here. So you can see I have made that particular line, or you can say a box on the other plane, which is connecting to my previous sketch or the sketch of my perpendicular plane which was previously there. In this way you can again make a plane on this side and on this side again, and you can make a cube again with the line diagram as well. This was how you can take different types of planes in angle, whatever you want, how much angle you want, and you can complete this diagram. I'll quickly make the planes on both the sides and complete this square quickly. Exit the sketch again, features, planes. I'll select a line for now, then the perpendicular one. So the second reference will be a perpendicular plane to this. So we'll see which one is the perpendicular plane. Again, the top plane is the perpendicular plane. You can also reverse the direction of this angle. So this will go to again 180 plus 90 again 360, or sorry 270. And we'll click on right button again. Then again you will right click on this and you can start sketching. Quickly I'll make another square on this. So you can see on that particular plane I have made another square which is on the top. Now we want a plane which should be on this and this line in the same line. Again you will exit the sketch, go in the features, planes. Again I'll give line as a reference. So my first reference will be this line. The second reference will be another line. So you can see the plane is appearing, which is connecting both the lines. No matter if the lines are not in a straight line, the plane will come automatically in angle if you give proper reference to it. Click on right button, start sketching on this plane, select line again. So you can see we have connected, or we have made a square with a line diagram by using different types of reference planes with different references parallel and with taking points and joints lines as well. You can unhide the planes if you don't want to see the planes. You can right click on this, click on this I button, and you can unhide the plane, sorry, hide the planes, so you'll only see the line diagram of the square which we have drawn. This way you can sketch and make anything by taking a reference plane to many different types and many different parts wherever you want to draw or wherever you want to sketch. After making this line diagram and finishing with the planes, I'll show you how can you apply some kind of material to this line diagram. You can see that we cannot extrude this as it is a 3D line diagram. So if you want to apply some material to it, and if you want to apply any kind of different kinds of materials like square, circle, bars, or anything. So there's a feature here called as weldments. So you just go into view. You have to first exit from the sketch. After exiting, we'll go in the insert option. There's a option called as weldment. In this, these all are the same options which you will get in this commands here. So it's nothing different here. You'll get weldments here. Go in the structural members in this. Here you have to put whatever dimension your sketch is of. I'll put ISO. For now, I'll take a round pipe, and in the group, you will select here in a clockwise or in an anti-clockwise direction every time. So this is your 1, 2, 3, and 4. In this way, you can add material to whatever line you want to. For the next line, you can just click on new group and you can make another group here. In this way, you can just add all the lines. Again, you go in the new group. Just click on right button. Again, you can see your material is added to the particular lines wherever you want to. Then you can just again click on the pipe and just edit the feature. I'll show you some more features in this weldments. You can see this circular pipes. The outings are coming out like this. So if you want to change that and if you want to make a good profile for it, you can just click on this box and you can select here trim orders, whatever you want to. you can again select this all ping points and select according to which you want to draw your or make your profile of. Just you can just after finishing all the ping points wherever you want to make the profile, you click on right button. You can see here the difference on the right side and on the left side. We have closed the profile properly. In this way, you can close the profile of each and every joints wherever you want to add the material of. So this is an example, just an example of a round pipe. If you go in the insert and the weldments, you have many different types of materials here which you can add, which is you can see C channel, angle line, pipe, rectangular tube. So you can select here whatever you want as a material on this. This was all about, you can say, weldments and how to apply a particular or a specific dimensional material on your line diagram. I'll just quickly delete this. After finishing this weldments, the next thing I will show you how to apply material on the particular solid 2D or 3D model which you have made. So again, I'll take a front plane, I'll make a 3D model here. Again, I'll make the same cuboid of 100 by 100 mm. And I'll extrude it again to 100. So for example, say that this is your 3D model which you have made and you want a particular mild steel, aluminium or some kind of material on this. You have to, you can see on the left side here it's written material. You can right click on this and select edit material. In this edit material, you will get all the materials which are available in the SolidWorks software. You can see there is steel, iron, aluminum alloys, copper alloys, titanium alloys, whatever material. If you are designing a tire, you can select rubber from here. If you are designing any part which is made up of plastic, you can give plastic material to that as well. You can give wood, rubber, depending on what product you're making. You can select from this and just apply on the 3D model which you have made. So click on apply button. You can see the material is applying on this our 3D model. You can also configure this if your values are not given here, and if you want a specific value to be added, you can also add this from this configuration. After applying, just cross this. You can see that the material is written here which you have applied on your 3D model. After this, I'll tell you some features from your 3D model features. In here, you can see that you can also take axis, means a reference axis, which I told you, which you can also take from here, hides and unhides. For that, I'll have to make a shaft to show you how the axis works. So I'll quickly delete this and make a circular shaft. So I'll just delete this. Features, extrude. If you have something circular like this and you don't know what is the center axis for this, you can go in this I button, or here also you have an axis. Just select on this. You can see there is an unhidden view temporary axis. So this hidden part you have to unhide it. You can see that your axis is appearing in the center of this particular circle, your whatever shape you will make. if you want to give reference for your mirror or circular pattern or any other thing as a reference line, you can use this axis and make different parts and different cut sections from it. So this was about axis. Not only axis, there are different kind of unhide and hide planes which you can hide from here. As you can see on the left side, the front plane, top plane are hidden, which you cannot see, right? So you can just right click here and click on show. So your face or your front plane will be seen every time. If you want to see a plane and if you want a plane as a reference for any other command like mirror. So this was all about many different features, other features which we have. Considering this commands, you can make any model which is complicated model. You just need to know what is going to be your approach to draw your model or your sketch. The good your approach is, your design tree will be shorter and you will be taking less time to complete your particular sketch. I'll quickly delete this and show you another feature. You can see beside your reference geometry, you have written curves. In this, you can make springs and helical and spiral curves, which are, you can say, present in suspension spring or any other spring which you want to draw. To use this splines or this helical spiral, you need to have two planes. So as I explained you how to take reference planes, by taking reference planes and making two, you can say two 2D sketches on different planes, you can make a spring kind of thing. I'll just show you a quick example of how suspension spring is made. So this is my front plane. I'll quickly draw the upper part of the suspension where the spring is connected. So there's a circle up here. So consider this is your front plane and this is the top part of your suspension. Now you need a bottom part where the suspension is the second part, second side of the suspension is connected. So for that we'll have to take a reference plane. Make sure you are exiting the sketch. Go in the reference geometry, plane. So we need a plane which is down of this, and this is a front plane. So your first reference will be front plane and you'll keep parallel to that. I want the direction to be reversed, so I'll select flip offset. And the distance you will select according to the suspension whichever you have and the dimensions you have. I'll keep it 160 for now. Just click on right button. In considering this example, I'll show you one more feature which is called as convert entities here. What convert entities exactly do is the entity or any sketch which you want on any other plane, which you have already on some particular different plane and you want it in the same sketch on the other plane. You'll just select convert that entity. You'll just click on convert entities. Okay, firstly you'll go and sketch on the plane where you want that entity. Then you'll select convert entity. After selecting the convert entity, you will select the face or edge or any sketch which you want to convert to the other plane. And then you will click on right button. You will see the same diameter circle will appear on the other plane. In this way, any sketch which is on the plane and which you want to be converted into other plane or other face, you can just select convert entities. No need to sketch the whole thing again on the other plane. After making this, quickly I'll extrude this one as well, 10 mm. So consider an example of this is the upper part of suspension, bottom part of suspension, and we need the suspension spring in between this. To use this option or command helical, helix, and spiral, you need to give two references, one reference circle on the upper face and one reference circle on the bottom face. So I'll quickly select this face and sketch on that face one circle. So I'll select a circle and randomly I'll give some dimension to it, 70 mm. And I need the same circle on the bottom plane or your bottom surface as well. Exit the sketch, select the down surface where you want your circle or you want to sketch, convert entities, select convert entities, select the sketch which you want to convert and just click on right button. The same circle has appeared on the down face as well. After you get your reference circles, you will go in the feature, in the curves, you will select helix and spiral. Make sure that you are exiting from the sketch. Go in the features, helix and spiral. One will be your bottom circle. You can see that the circle which I have made on the bottom part is getting a spiral shape here. From this helix spiral, you can keep the pitch of your spiral spring or suspension spring or any spring variable or constant. You can select here what is going to be your pitch in between two springs. You have to select here how many revolutions you have in your spring. So you can see the spring will increase according to the revolutions you will give for that particular spring. You can give it till the end. After that, you can give particular angle if you want any between that spring. Just click on right button. You will see that your spring will appear here. And then if you want to give some particular shape or dimension and material to it, you will go in the sketch. So you'll go in the surface and select your swept boss option. And in the swept boss option, I'll go for a circular profile and select this spring here. You can see that your circular profile is appearing here. And you'll click on right button. You can again change the dimensions in the sweep options as well as I explained in the yesterday's session. So you can see that we have got a spring, you can say a suspension spring in this. By changing the number of pitch, diameter and diameter of your spring, you can edit everything. In this way, you can use your curves and splines and your spring option, or you can say your helix and spiral option to make different parts of your springs. So we'll move ahead to our model. Today we'll make a cylinder, starting with cylinder. I'll just quickly delete this. I'll hide this plane for now. We'll take a new and start making a part. So here I have two dimensions, one dimension for our cylinder and one for our crankcase. We'll try to finish both these models. So before starting with any of our model, we have to take care about the dimensions given in this. So each dimension is in mm as it is written here mmgs. So before starting any part, again we have to take care about the dimensions which we are going to start with the model of. You can see there are different, all the dimensions given for this cylinder or for IC engine. We'll start quickly drawing from the front view. To make any model, you will get this sheet which is called as drafting sheet. On this you have all the views, cut section views and detailed views in this for the dimension of your whatever model you are going to make. This is the front view, this one is the top view, this is your side view, and the section which is written here, cut section from A to A, means this is your A, this one is your A. So this is the cut section in between this. Then you have a detailed diagram of your B. So you can see here B written. This one is your cut section B, of which the dimensions are given. And then the C means this one here. It is written C. So this, according to this, they have given all the dimensions to make our cylinder. We'll quickly start with the part of our cylinder, and I'll try to make it as easy as possible for you all. We'll go in the part. Firstly, make sure the dimensions are mmgs. We'll take the front view. So we have the dimensions of the fins as well. We'll quickly start making with the half part of this section like this with the dimensions given. Quickly we'll start with the center line in between and the right part of your cylinder. Quickly take a center line in center and make one center line. Then we have to make the start from anywhere, bottom or top. You can see this part is 35 mm apart from the center line. So I'll give 35 mm here. Then you can see this line is on 75-degree angle. And the height of the line, the dimension for that particular height is not specified anywhere. So we'll quickly assume that. To take an angle from down part, you also can extend a center line and give angle to it, or you can just minus it from 180 and also can give angle from the other side as well. 75. For now, I'll just keep it 30. We'll try to see if we get the dimension of it. Mostly the dimension is not specified, so we'll keep it 30 for now. And we'll start making the fins on the upper side. I'll just zoom for that. There are two dimensions. One is here and the other one is here. So from the down, as you can see here, the distance from outside to this line is 20 mm apart, and the distance from the inner hole to this point is 6. So you'll minus 20 by 6, it will be 14. So we'll make a straight line on 14 and try to make this curve with this given direct dimension, radius as 1.5. So from here inside it is 14, and you have a circle of radius 1.5. The distance between those two lines is specified as 3 mm. So I'll keep 3 mm for all the fins here, which will be symmetric as well. Quickly we'll offset the entities of this line, or you can make a 3-point arc curve and give another line to it. And the radius of which is 1.5. And quickly we'll make another line outside. And one more curve to it. This is again your 1.5. In this way you can quickly make the fins. There are, I feel, number of fins are 1, 2, 3, mostly 3 or 4. So we'll make 3 for now. So quickly complete this. After making this 1, 2, 3, we'll go with the square one. As you can see, the dimension of the square is given 3 by 3. So the distance is also 3. And the center distance is also 3, given as 3 mm. So we'll quickly finish that part as well. And that is a simple square. So I'll just quickly make it. Make sure you're keeping it till outside. Just here it is 1 2. Okay, so I'll just add 2 more pins to it. And quickly give some dimension to the same. Both the dimensions are 3. Just quickly give the dimension to lines here. After making this number of fins, we'll quickly connect this part. We'll see if any dimension, specific dimension is given for it. So there is no specific dimension given for the height of the cylinder. You can make it out from here, which is 68 plus 37. So it is 105. For that, you can give dimension to this center line, so you'll get a idea about how much it looks. So 105. So you can just add some fins if you want to. So I'll quickly add some fins here. You can also make this circular so that you don't have to delete it. And again, give dimension to it. Make sure you're deleting the dimensions, otherwise it will overlap the dimensions. So it's already 1.5. Do it same for this as well. I'll increase the upper part more. Select line. Quickly give dimensions of the fins again. After making this, you just complete it till up. See where the line is. Here it is. So it's completed there. We have made this right hand side of our cylinder. I'll just quickly complete this. Make sure you're not keeping any sketch incomplete. You have to complete it. After making this, we will use here revolve option. I'll select revolve option. And as you can see here, you have to give reference axis. So I'll give this center line as my reference axis. And in the counters, I'll give the center one. You can see we can just revolve that particular part. Just click on right button. So you can see that we have made the outer part of our cylinder. You can quickly complete the down part and the upper part as well. You can see there is a hole here inside, which the diameter of the hole is 54. So we'll quickly in the center make a hole of 54 in the down part. Please see the dimension. So the diameter is 54. We'll just select this, exit the sketch, select the surface and sketch on it. Go to normal and give dimension here as 54, and you have to remove the material from it, and the distance for that is 71. You can see here. So I'll quickly go in the features and extrude cut this to 71 distance. So here I'll give 71. You can see it is cutting till half. Just click on right button. Okay, you need the cut in the base as well. So before extrude cutting this circle, we'll quickly make the base and then cut this circle. So I'll just edit this sketch, and instead of this circle, we'll make a base here. Delete the circle. Take a center rectangle. Just make one rectangle and start with the dimension. We'll quickly take the dimension of the base. So the dimension of the base, as you can see here, it is 85 by 85. So quickly we'll give dimension to this rectangle as 85, and the side one also as 85 again. And we need to extrude this to particular thickness, and the thickness for which is 5, as you can see here, 5 height. So I'll quickly extrude this to 5 mm. After making this, you can go quickly make the circle which I showed you, which was of 54 because we need that extruded cut in the base as well. '54. Quickly cut this to a height of 71. You can see your hole has cut to 71 only. Quickly we'll go in the upper side and make the upper part. We'll see the dimension for it. We have a fillet here which is 5 into 41.99 degree. So we'll just round figure it to 42 degree. So we'll go again in the fillet option. And here you can see, so it's not a fillet, it's a chamfer. Yeah, it's a chamfer, so we need to select chamfer from here. And here instead of 10 it is 5 and instead of 45 it is 42 degrees. Click on right button. Then you have to make two holes inside, as you can see in this 3D sketch, 3D model, sorry. These holes are about 12 diameter, as you can see in this, and those holes are till this inside, you can say, chamber of your piston. So you need this 12 diameters apart, and the dimensions for them is given here down, which is 36 So we need to make a center line. I'll quickly select the upper surface and we'll make a center line or midpoint line, which will be apart at 36 Make two circles of 12 here. Quickly give dimension to them. 12, 12, and then you can just delete this line. Now you need to cut this till the down cylinder. We'll go in the features, extrude cut, and here, as you can see, it is blind. You can select here up to next, so you can see it is only cutting to the part of the inner cylinder which we cut, and you can click on right button, so you can see the holes from up as well as from down, which are connecting to the cylinders which we cut. And we'll see what else is remaining. We have to make this C section, which is an ellipse. So the dimension for which is 36 and this height is 16. So we'll try to make this on the right side of your cylinder. To make that, you will have to take some plane again. We'll see which plane is parallel, so we'll make a reference plane for this. I want my plane parallel to my right plane, so I'll give right plane as a reference. Just select the view, and in the dimension, in the distance, I'll select the distance I want. So it will be most probably 50. Try with 45 and click on right button. There must be some dimension given for this as well. We'll check it in this. So it is going inside of the cylinder, as you can see in this. We'll quickly make this on the side plane. You will right click on this plane and sketch on this plane. Go to normal and we'll make an ellipse. We'll see if any dimension is given for the height as well. Nothing such dimensions are specified here for the height. We'll do it in the upper side. No. So we'll quickly make it on the upper side of your cylinder. On here, we'll make a center line for that. And down as well, one more. After making the center line, we'll go for an ellipse here, and the dimension for which is 36 by 16. So we'll start from the center of this till this, and the dimension for which is from this to this side is 36. I selected the wrong line for dimension. Your 36 divided by 2 will come 18. So your other side will be again 18, which is 36, and then your height is 16 again. So this is already 8.20. I'll do it 8 here, which will be your 16. And we'll make it straight. We'll select on the point, select on this point, make it coincide. So we've got the ellipse here, and we'll make the inner circles as well. The middle one is of 10 diameter. So we'll make a circle of 10 here. And there are more two circles apart on 13, and the diameter of them is 4. We'll quickly make 2 more circles. And the diameter is 4, and the distance is 13 from center. We need the same distance circle on the right hand side. Quickly mirror it with the circle reference line. So we have done with the part here. We'll just extrude it inside. Just go in the features, extrude, change the direction in the inner side. You can see it's going very far. You can do here up to next. So you can see the part which we have, the hole which we have here, till the next it will go and extrude. Click on right button. We have made that particular part here. Let's see what it is also on the other side as well. And there is a pure hole till that. So we can just quickly extrude, cut the inner hole which we have here. Just sketch on this surface. Make the same 10 mm circle here. And just quickly extrude, cut it to the next. We'll get a hole to that. So after making this, you will quickly mirror it on the other side. Go in the mirror option. We have to select a plane for mirroring a solid model. We'll do full preview. For the face, I'll select the middle one, which is the right plane. And now this is a body, so we have to select it in a body that you want to mirror this one, this particular body. You can see the whole part is selecting. You can again edit the extrude boss option, and you can remove here merge result, because of which the whole body was selected. And we'll go in the mirror option again, in the face, right plane, in the body, your extruded one. You can see it on the left side in the preview, and you'll just click on right button. You will get both on the other side as well. So this is all about your cylinder. You can see there are 4 holes as well down. We'll quickly make that holes and go to the next part. That holes are again 6 diameter, 4 holes on 8 mm apart from both the sides. And there is fillet for the base, which we have forgot to do. So we'll quickly make the fillet and make the, if you don't want to see this plane, you can just right click and hide the plane. Just select fillet, and the dimensions for fillet is 3 radius. We'll select all the 4 edges, and the radius here is 3. Make sure you're selecting only edges and not faces. Click on right button. We have done the fillet. Now for the 4 holes, I'll select the down face and sketch on the down one. Go normal 2, and we need to make 4 holes on 8 mm apart, and the diameter of which is 6. Quickly we'll make holes here. 1, 2. We'll give dimension to it from this side to this one. How much was it? 8 mm, right? So 8. The diameter of the hole was 6. One more dimension is left. The distance from this to this line is also 8. The same thing goes for down. Dimension of circle is 6, and the dimension from this horizontal is 8, and vertical one is 6. Sorry, 8 again. We've got 2 circles on 2 sides. Quickly make a center line and invert that on the other side, so you don't have to give the dimensions again and again. Mirroring 1 circle, 2 circle. Mirror it on the left side. Click on right button and quickly extrude, cut and remove the material from the base. So you can see we have completed our cylinder of our IC engine, and we'll go for the next part, which is our crankcase. This cylinder is eventually going to fit on this particular part which is there on the crankcase. So this is a radial IC engine, you can say. So we'll start with this crankcase now. We have completed with the cylinder one. We'll quickly save this. We'll quickly start with our next part. Just cross this, again new part. We'll start with the crankcase now. Again, they have specified a material here. Their dimension is given in mmgs. All the holes are true all unless specified otherwise. According to this dimensions, we'll quickly start making our crankcase. We'll start with the bottom one. So we'll start firstly with this circular diameter, which is, you can see this is a center line, so this is not the outer one. This one is your outer one, and that is your 200 mm. So first we'll make a 200 mm and then we'll make the inner one as well. Again, select a front plane, sketch on it, take a circle, make a circle, 200 mm. After making this, we'll see what's the height of it to extrude. So you can see here one height is given 124 and one is 130. So minusing this, the upper part which is coming up here is your 6 mm height. So I'll quickly will extrude this outer part to the height of your 130. You can take 124 and you can extrude this outside afterwards. So for now, we'll extrude this at 120, 130, sorry, 124. You can see that this part is hollow. So we need to also cut the part till inside, and the thickness of which you can see here is this one is given 8. So 8 mm is your thickness, I suppose. No, you can see from the top view, this is the top view, and this is the upper part, which is the outer one, and this one is the inner circle. So your inner circle is about 160. So the thickness for your inside is 200 minus 160, which will be 40. So quickly you can even cut this on this surface or quickly use the shell option here. We need this surface to be removed, and our thickness is 40. Just click on right. Then you can see there are different dimensions given here. You have to cut a hole inside. So this is actually a diameter. So 40 will be on both the sides. So 20 from here and 20 from here. So that will make the thickness as 20, not 40. We'll quickly edit this from here and make it as 20. After making this, we have got an inner shell. We'll quickly make the upper part for this, the upper one, and the diameter for the same is 160. And the outer one, they have given the thickness as 5. So the other one will be 165. We'll try to make it with some command we learned. So firstly, we'll start sketching on this plane. We'll make a circle of 160. And you can see there is a extrude cut also inside this and an extruded part outside as well. So the extruded part outside is given here, which is 12 mm from the inner part. As you can see, this dotted line, which is the inner one. And the outer one, if you can see in this, so that will be minusing your 12. You can see here the thickness given. So this is 124 minus 130 minus 124. So it will be 6 mm outside. So this will be 12 minus 6. So 6 inside and 6 outside. So we'll quickly extrude this outside at 6. You can extrude this and cut inside by 12 mm. And also you can do one thing. You have to cut it, obviously. If you want to extrude the circle, you can select offset entities and select this circle and give here 5 mm dimension, which is given here. If you can see in this 5 mm. So we'll only extrude the circular part and then cut the inner part by 12 mm. So I'll just extrude this out by 6 like this, and you have to cut this. So again you will sketch on this and cut this inside by 6 mm. Again you have to make a circle again there. You can also use offset entity for that. Extrude cut 6 mm. You can see the direction where it is going. It is the inside outside. Just cut it. You can see that we have extruded it outside as well and extrude cut it inside. There's a hole inside here. The dimension of that hole is 35 diameter. So again, sketch on the surface. Go to normal and make a circle of 35. So it's a diameter. So 35. And just extrude cut and remove the material till the next. We don't want a blind or 6 mm here. So just select here up to next and just remove the material from this. After making the hole, we'll try to make the upper part. So as you can see in this dimension, you can see this. We are going to make this part for now. The dimension for which is inner circle is 10, and the outer radius of the arc is 10 radius and 10 diameter, and the radius of the arc is 18. We have an outer diameter as well, which is 220, the dotted line. So first we'll make this construction circle and then we'll try to make this one. Quickly we'll go and select the surface on which we want to draw. I'll select this outer surface and we'll make a circle of 220 mm here. We have already a dimension given here, so I'll just edit this one, 220, and we need this circle to be a geometric circle, so construction circle, sorry. So we'll select your construction geometry. Just for reference, make a center line, and we'll make one part of this here. So the dimension was first small hole of 10. Make a circle of 10 here. Then there is one more semicircle which radius is 10. So I'll make one more circle here of diameter 20. And quickly with the trim from the inner part. After getting this, we'll connect this with arc. Take a 3-point arc. And connect this arc down with this circle. So sorry. If the arc is not coming tangent, you can just select this, select the arc and click here command tangent. Same thing goes further down as well. Click on the arc, press control button, click on the circular edge, click on tangent command, press right, give dimension to this, dimension for which is 18 radius. Here. Okay, so the dimension here it is already mentioned. Just delete this dimension. If your diagram is over defined, then it won't take it. Make this as radius as 18. Just delete this one. I'll quickly make another one. Trim the inner part. Again, take a 3-point arc and the inner one is 10 diameter. Take a 3-point arc and just connect this. Give radius for it as 18. We want the same arc on the right hand side, so I'll quickly mirror this as we have the center line. Select the arc, center line. After making this, make sure you don't keep anything incomplete. Your sketch should be fully complete. So I'll just quickly join this 2 by 3-point arc again. So we have made this and now we need to extrude it. So I'll just see the height of this. The height for which is specified here as 12 mm. So we'll go in the features and extrude that. You have to see the direction, where is it coming. If it is outside, you can just flip the direction from here, and which is 12 mm. Just click on right button. You can see we have got one. Make sure again you go in the features and edit when you extrude your anything. If you don't want to merge that result, you can untick the box of merge result from here. I can quickly, if you can see in this figure, there are 5 number of 1, 2, 3, 4, 5. So we can quickly make a circular pattern. So I'll show you circular pattern in how we can do it in a 3D model. Again, in the circular pattern, we'll select circular pattern. Firstly, it will ask you the direction. So we need to have axis here for the direction. And for that, as I explained you earlier, here you can get a temporary axis, which is hidden axis. And you can select in this direction as this axis. And down here, instead of features, we have a body now. So we need to select, instead of features, we need to select bodies. And in bodies, we will click on the part which we want in a circular pattern. We can put here number. Now it's default 5. We need 5 numbers. Just click on write. This way you'll get this all the 5 bodies which we need to have a circular pattern of. Then we'll go to make this box which is here, on which your cylinder is going to rest, which you will do it in assembly. So in this dimension is given in the earlier picture of our cylinder, so that was 85 by 85. So according to that, I'll make the same dimension here. So for that we need to take a plane again. Again we'll go and take a reference plane for this with the features planes. See, make your view properly. Take any plane which is parallel to your right or top plane. You can see this properly, it is on the surface. You can start sketching on this again. Again go to normal. We'll make a rectangle here from the center of it. You can see if you just move your circle on the line, he will show you the center point of it, and we have our origin already in the center. This is why you should take your any part or model, you should take your origin in the center for it. Quickly give dimension to it, 85 by 85. You can see there is also a circle in between. That circle was of 54. We'll make a circle as well. 54. We'll quickly extrude cut this in the cylinder part. So features, extrude cut again. And the width of that particular box was 5 mm. So we'll keep here as 5. You can see we have cut that particular part. We need to also cut this circle out of it. We'll edit the sketch again, sorry. Exit the sketch, select the surface, sketch on the surface. As you can see in this, the circle is cut through, so we need to cut the circle through. For that again we'll go in this, edit the sketch, and we'll delete this circle from here, exit the sketch, and on this surface we'll again draw one circle which will be of 54, again from the center. Go in the features, extrude cut. You can cut it up to the next, just click on right button. So this is the part from which your piston will come in inside the cylinder, which is going to rest on this square part. And there are again 4 holes here of 6 mm, which were 8 mm apart, which dimension was given in the other part. So I'll just sketch on this face again, go to normal, make a center line, which is going to be good for your mirroring option. Again, make 2 circles on one side. The diameter was 6 and the distance was 8 mm from both the sides. After making this, we'll quickly mirror it on both the sides. So one circle, mirroring it on the other side. Okay, this is the axis. We don't have a center line here. We'll quickly make one center line and we'll mirror it, the circle, the center line, and quickly mirror both these circles on the other side. And just extrude cut them to the next. So we have finished doing it this with one cylinder. In the picture or in the sketch given, we have 5 sides for 5 pistons. So we need this on a whole cylinder equally distanced on a number of 5. So we'll quickly again go for a circular pattern. If you don't want to see this plane, you can just right click and hide the plane. And again, we'll go in the circular pattern here. Again, the default number is 5. We need 5. Again, in the features, we need bodies. The axis of revolution reference axis is center axis. And the bodies, we need to select this part. As you can see, there are number of 5 coming in equal spacing. Just click on right button. As again, while extrude cutting, you can see that it might be taking the shape of the inner cylinder as well. You can select the same from your circular pattern again. Sorry, we need to select bodies. Select it properly, otherwise the circular pattern won't come rightly. So you have to select the bodies properly. As you can see, it is taking the whole face. And the circular pattern again, axis of revolution. We'll try to get the pattern of the features. So we need these 3 features to be patterned circularly. Click on right button. So no need to draw whole part again for 5 times. We can quickly make it by circular pattern as well. So this is the completion of our second model, which is our crankcase. Mostly everything is covered with the dimensions given, as you can see here. We'll again quickly save this. So this was it for today. If you have any doubts, you can just put it in the comments section. We'll wait for some time.
Okay, so guys, we are done for today's session. So please let us know if you have any doubt or any problem that you have faced so far. So you can write your doubts on the chat box here, and we will see to it. We will wait for another 1 minute, and we'll see if any doubt comes up. So we will take that, and we will wind up for the day. Okay, so there are no queries. Okay, so we will end this session here for today. So thank you everyone for joining us on this session today. So tomorrow we will again continue at 9 p.m. So those who would like to join us tomorrow, please be there, and we will be happy to share all these things with you. So thank you for the day, Pratik. Thank you for sharing all this.
Thank you, sir. Thank you so much.
Yeah. Thank you, everyone. Good night.